So, hello and welcome to our second class in under the topic function of a function. My name still remains Yemi, a math tutor on this platform, and our objective for this class is to interpret functions using the function notation. To interpret functions using the function notation. Okay. Now, coming from the background of the last class, once we determine that a relationship is a function, we need to display and define the functional relationships so that we can understand and use them, and sometimes also so that we can program them into computers. There are various ways of representing functions. A standard function notation is one representation that facilitates working with functions. Now, to represent height as a function of age, we start by identifying the descriptive variables. Okay? We start by identifying the descriptive variables. For instance, h is used to represent height. H here represents height. Okay, I can see here we name the function f. Height is a function of age. Okay, your height is h, while your age is represented with a. Okay, which are the variables? Now the letters f here is used to represent the function. In other words, the rule now is not only f that you can use to represent functions. The letters f, the letters g, and the letters h are commonly used to represent functions. Okay, just as we use x, y, and z to represent numbers, and then also a, b, and c to represent sets. Okay, now we name the function f. Height is a function of age. Our height is h, our age is a. We use parentheses to indicate the function input. Okay, we use parentheses to indicate the function input. As you can see here, our input is a, so we put a in parentheses. Okay, and then finally we name the function f. The expression is read f of a. So as you can see here, this expression is read f of a. Remember, we can use any letter to name the function. Also, the notation, if you have something like here you have f of a. If you have something like h of a, shows us that h as a rule depends on the input a. The value a must be put into function h, okay, to get a result. The parentheses indicate that age is input into the function they do not indicate multiplication. Okay, it does not indicate multiplication. What it means is that A is input into this function to give an output. Okay, we can also give an algebraic expression as the input to a function. For example, if you have something like f of a plus b, where f is a function, okay, what we are simply saying is that the input to this function must be the sum of a and b. That is, you first sum the variables a and b, then before imputing it into the function. Okay, the operation must be performed in this order to obtain the correct results. Let's quickly look at in summary, the notation y equals to f of x defines a function named f. Okay, it defines a function f. Okay, defines a function f. This is read as y is a function of x. The letter x represents the input into this function, or the dependent variable, the independent variable. The letter y represents the output, okay, or the dependent variable, as the case may be. Let's quickly look at an example to buttress what we have been trying to explain. Example 3, as a continuation from the last class, says use function notation to represent a function whose input is the name of a month and the output is the number of days in that month. Assume that the domain does not include leap year. Okay, now note that the number of days in a month is a function of the name of the month. So if we name the function f, okay, we name the function f, we write days, okay, let's write this one well. We write days, okay, equals to a function of the type of month. Okay, the name of the month is the input. Okay, the name of the month is the input. The days is the output. Okay, while this f here is the rule or the function. Okay, if we represent days by just d, okay, and we represent our month by just m, then we have been able to use the function notation, okay, to represent a function whose input is the name of the month and the output is the number of days. Now, for example, if our input month is January, for instance, okay, if our input month is January, what we are saying here is that how many number our output is going to be 31 days. That's the number of days we have in January. Okay, so if you write it this way, you are going to be perfectly correct. Okay, also if we change this input, for instance, to March, okay, our output is still 31. Okay, so what we are saying is that the notation D equals to F of M reminds us that the number of days D, which is the output, is dependent on the name of the month M, which is the input. So if we change our input now again to, let's say, September, alright, it's not well written. Okay, let's say we change it to the month of September, then our output is going to be 30. Okay, now note that the input to a function do not have to be numbers. Okay, function input can be names of people, labels of geometric objects, or any other element that determines some kind of output. Okay, now let's look at the second example to portray what we have to see. Okay, the question says a function n of n equals to f of y and give the number of police officers n in a town in year y. What does f of 2005 equals to 300 represent? Okay, right away, looking at this, the function has been defined and they give us the numbers. All we need to do, we need to just read. Okay, if we say f of 2005 equals 300, remember n equals to f of y. Okay, the statements f of 2005 equals to 300 tell us that in the year 2005, okay, there were 300 police officers in the town. Okay, as simple as that can be. Okay, now it's good for us to lay our hand on some examples to show that we actually understand this concept. Okay, so I'm going to round this class up by giving some exercises that you can just copy down and then try on your own. So no answer is provided. For instance, the question says use the function notation to express the weight of a pig in pounds as a function of its age in days. Okay, these are very simple questions. Question 2 says use the function notation to express the height of a tree as a function of its age in years. Okay, this also is a very simple question that you can use to practice. Also, number 3, I added some little extension to number 3 to make you stretch the brain a little. The question says a function v equals to gt gives the volume of water in the tank per minute. What does g of 5 equals to 1000%. Okay, I believe this first question is covered in this very explanation, the previous explanation. But I have at the last page says, given that G is a function, what is the rate at which the water level in the tank rose per minute? What is, let's put it here, what is the rate at which the water level in the tank rose per minute? Okay, this also is a very simple question that all you need to do is divide the total volume by the number of the total time that was used to fill the tank, and that will give you the rates. Okay, the rate is actually going to be in volume per minute. Okay, so thank you for being a wonderful audience. Try this out in your immediately pause this. You can pause this part of the video and try this question out, at least to lay your hands on some things and practice, because practice is the soul of mathematics. Okay, lay your hand on this, practice them. I'll see you in the next class. Thank you for being a wonderful audience.